Hello. Hi. Welcome to another webinar on practical implementation of AI and machine learning in the real world. My name is Akash Takyar. I'm the founder and CEO at LeewayHertz. We have been building enterprise software solution for the last 15 years. And we have been working with several organizations from startup to enterprises and implementing AI strategy. And during this experiences that we had, we have created a framework and an approach. How do we apply AI within an organization? So today, what we will do is we will walk you through maybe a use case of what kind of a case study, what organizations are doing in order to implement and how they are implementing AI. And then we will drill down a little bit more on what this strategy look like and what are the building blocks to be AI ready. And also we will touch base on actually building the proprietary LLM. We will not go too technical and detailed today on this one, but we will take questions at the end of it. And at the end, we will give you an approach of how you can execute an AI strategy within your organization and do it very, very quickly and build some use cases. So today I'm joined here with my co-host, Deepak Shokeen, who is CTO at LeewayHertz. Welcome, Deepak.
Thank you, Akash. And these are exciting times that we are living in. Everyone is wondering on how to integrate AI into their processes, whether they are internal or external. Large companies has already invested in it. Medium to small companies are gearing up. And for that matter, we are also trying to implement most of these tools across our processes. So yeah, I'm excited.
Same here, Deepak. So let me begin with a quick demonstration of a case study of what is possible when you implement AI within an organization. So let me share my demo screen. Okay, so what you see here is a tool which has been built for an organization. And what this tool is built on a platform called ZBrain. And the way it works is once we have done all the building blocks in an organization, then you are able to give this tool access to various people in the organization, and they can do and solve various use cases. So let me start by beginning with how this tool actually works. So what you do is, what you see on the right-hand side is the list of various agents that are available. Now, agents in this context are AI and various large language model and some skill set that these are put together, where these agents are able to do self-prompting and being able to solve a problem. So let's say we give an input to the agent, then the agent is able to query through a large language model and try to get to an output that is expected out of it without getting user involved in the middle. And of course, the agent has access to various tools. So right now on the screen, you will notice that Analyst Sam is selected. Analyst Sam has access to the Google search, and it has access to how to do research on LinkedIn. It has also access to Gartner large language model, then some databases on Duns & Bradstreet and TrackXM. And then it has the ability to also do website scraping. So this particular example, I'm going to ask Analyst Sam that I want to do a proposal for a company called Aquara. And once I upload a document, then the agent is able to propose that whether I want to do a proposal or I want to do a development plan or what I want to do. So let me say that I want to do a proposal, and then it asks what kind of a proposal you want to create. So if you notice here that these are not like just only using the OpenAI or open source models. What we're doing is we're using the proprietary archive, the company's archive, to be able to come up with and train and fine tune these agents to be able to ask the right and relevant question. So the process is, once I choose the type of proposal that I would like to build, and in this case, I said I want to do a business process improvement proposal, I'm presented with a screen where the agents are going to work together with, and produce results. So what you see in the middle of the screen is various sections of the proposal that has been produced. So on the top, you see about Acquira that has been put together. There is an image. Maybe this image has been created with a diffusion model, and that can go into the proposal. You can see here it says generated by analyst Sam. It's a little bit gray out. And then it has used Acquira.com. It did a Google search, and it used the GPT-4 model to be able to produce this paragraph. Now, when producing executive summary, analyst Sam used Salesforce because there is a lot of critical information which resides in Salesforce for this organization. So it was able to go through the dispositions and call logs and history of emails for this particular customer to be able to figure out that in this relevance of the proposal, what will be the right executive summary to put in. Now, as a sales associate of this organization, if I want to change and I don't want to, I don't like this particular executive summary, I can always give it a feedback. I can refresh it, and I can always change and use a different version. Now here, the feedback is also very important because there is human in the loop, and we will make sure that the feedback that comes out, we are keeping a record of the prompt and the completion that happened in the background. And then we are using that to fine tune the model going forward. Although the larger implementation of this will be doing RLHF process, but here in this particular case, we are doing it, that process is very manual because the data set is very small.
Right. And just remember, this is all being done by analyst Sam. So considering the principle of data segregation, there is a separate PM Rachel also, which is also acting as an agent here. They both have access to separate databases. So let's say now PM Rachel has to collaborate in generating this proposal. So what it has access to is, let's say, Jira, Workday, which contains all the data for a team member, like their work schedule, their task, their role. And based on all this information coming in from these tools, using the proprietary LLM model that we have created for this company, this agent, this PM Rachel, is able to suggest team members that can work on this specific proposal for this specific project. Yeah, Akash.
Now, you may ask, like, why do we have multiple agents? Why can't we just give the access to the same agent, all the database in the organization? And that's a fair question. And the answer to that is that you don't want the access to the agent to also go company-wide. So for example, the agent analyst Sam here in this case is being used by sales team. However, the PM Rachel has access to sensitive data around people and human resource. And you do not want the analyst Sam to be able to work with PM Rachel and access some critical data. And either you want your people in the organization to be able to query PM Rachel to access any confidential information. So that's why you want to keep at the organization level the agents, the knowledge bases a little bit separate. So now we have seen this example. Let me switch my screen back to the presentation. Now the question becomes, like, how do we go from being, not AI ready to becoming an AI ready organization? So let me just do that. So we believe in a vision that every organization must become AI ready and then strategically apply the AI to enhance the business operation and decision-making process. And this is very, very important vision. And this is a vision while working with several organizations we start to work with.
And this journey towards becoming AI ready and applying AI strategically isn't just about staying competitive. It's about reimagining how we operate, make decisions, and deliver value to our customers. Now, while getting ready, there are multiple aspects that an organization needs to consider while implementing this top-down enterprise strategy. So we have tried to define it in like multiple, I would say, buckets. The first one here is establishing AI readiness, which consists of the most important aspect, which is the team that will basically work towards this strategy. So one of the important team member is chief AI officer. This is the person who basically understands the processes, internal processes, external processes, understand efficiency, understand team. So this is the one person who basically takes decisions. Then comes service providers. These service providers are the you can say vendors or companies who has already worked upon multiple use cases of AI, who has consulted multiple enterprises, organizations, or who has built tools and products across AI domain. Now, when we're talking about these service providers, as a team, you might want to take decisions of build versus buy as well during this stage, based on the tools that they have worked upon. Another aspect is the internal team, which is maybe AI engineers or our technical team. The other team members that are required, who are basically working on these use cases end to end on a daily basis, understand the data, understand the process that is required, and the domain. So that's the team for you. We also need to consider from a technology perspective, like what all AI platforms are available in the market. So these could be open source AI platforms like Llama Index, LangChain, or these could be proprietary AI platforms. As Akash mentioned, ZBrain is one of them. We can consider GPT Enterprise version also. Then comes the most important aspect of these engineering, which is data engineering, because that's where most of the time goes. And we'll talk more about data engineering in our further slide. Then there are LLM models needs to be considered, public versus proprietary versus which are open source. And then there could be some domain specific models that might be required to be developed. So considering team and tools now, since we are ready, we would like to strategically define the application of AI across the processes. So identify the use cases as one of the first step, where you might want to consider, let's say, 10 different process and 20 different use cases across these processes. And then you pick like 3 most impactful use cases. So when I'm saying 3 most impactful, that's like the first step towards getting yourself enabled and making sure that we are ready to implement these 3 use cases. Coming to incubation and validation, where after you are prepared for implementation, you have identified these impactful use cases, you would like to quickly get into the process of demonstrating what are the results. Once you have implemented these 3 use cases, see what are the results, whether they are impactful or not. And then accordingly, you will optimize and prioritize your initiatives. Maybe some use cases gives you very good results in this first go. Few use cases might not be that impactful. So that's why we just need to keep optimizing and keep prioritizing these use cases. And moving forward, which is like very important layer, which is AI governance layer, which is on top of all of these use cases or the entire architecture or platform that we are trying to build. Kash, you wanna talk
Yes,
about?
let me add that. So I believe the biggest question that we have seen people have in their mind is how do I make sure that there is governance? Because these models are all over the place. They have access to the knowledge base, and there are a lot of business risks involved. So it becomes very important to understand how do you be ready and how do you apply the business AI governance within your organization. So there are a few things that you do. Of course, you need to be compliance ready. So let's say you have healthcare data and you want to be HIPAA compliant. You may want to make sure that you have replaced the identities and everything else with synthetic data before it is sent to the training of the model. So that's like being compliance readiness. You understand the compliances, and there are a lot which are coming into action, and there will be a lot more requirement down the line to be able to produce data for AI modeling. Second aspect will be business rules. And business rules are not only that applies to people, but these rules will also apply to agents and the large language model. You will create a lot of negative cases where you don't want to answer a question. You want to make sure that your model is uh, optimized to not access information which is irrelevant. So of course there are a lot of business rules that needs to be in place as part of your governance plan. And third one will be to provide immense amount of training, and there will be a lot of time spent within organization to train and to do mentorship within the organization with the people to be able to understand the compliance and the risk involved in accessing any sensitive information through models. One last aspect will be that you will have continuous audits and control in place, which will be continuously monitoring the response of AI agents and AI models to be able to make sure that they are within the boundaries that you have set as the organization. Now, when you have to roll out to the entire organization, and let's considering you are a large organization, we call that process as industrialization, where you have to create and now figure out how do you build an AI pipeline based on organization goals, the outcomes that your business is expecting out of it. You will put together some performance metrics that once you apply the artificial intelligence, then what will the metrics that you have as of today, and how do you link it to your business function? And then you will also make sure that you don't over apply AI to every process. You have to see activity level measure and see what is really relevant. So I think these are very logical steps you do. But during the industrialization process, there is a lot more hand-holding that is required to make sure that all of these aspects are in place. Now, what we will do is I'll let Deepak explain how do you really build a proprietary large language model, and we'll keep it at high level and not go very deep technically on these. Go ahead.
Sure,
Deepak.
Akash. I'll try to do that. So, as part of this whole building a proprietary LLM model, there are multiple, I would say, steps to it. The first step is data preparation and engineering, as I mentioned earlier, because this is like one of the most time-consuming tasks in the entire process. So to start with data preparation, let's talk about selecting a data. Now, when we are saying selecting a data, this data is pretty much data which is available within organization, and it is like available in structured, unstructured format. It could be available through all the tools that is being used in the organization. It could be emails coming in to various employees. So that could be another data that might be there. Unstructured data also consists of a lot of documents that are being generated, a lot of Excel sheets, a lot of PDFs, presentations. So that's all is considered as unstructured data. So, so you have to basically just bring in all that data. Now, structured data could be data like in big organizations, they already have data pipeline available. Then there are databases available. There are so this is what we have to consider while selecting the data. The next aspect is the data source. Now, this is something which is might not be available within organization. This is more or less sourcing data for a given use case, and this sourcing could be from any public data source that is available, either through APIs, or you go and do search on Google, as we were showing in our example. So those are data sources, and different use cases might require different data source. So you have to consider that. Synthesizing data is something. So let's say there is a huge data that is required in order to achieve a specific use case. You might not have that data, so you might go for synthesizing that data. Maybe you can use large language model to synthesize data using some of the limited data that we already have. And finally, as part of data preparation, you might want to bring all this data and consolidate it at a centralized place. It could be any centralized tool that is available through these managed clouds. So that's more or less data preparation. Let's talk a little bit more around data engineering, which is exploration. Data exploration basically consists of you might want to profile the data, which is understanding the statistics, understanding different attributes that is available, and grouping of that data basically covers as part of exploration. Once you have explored the data and you understand what data can be used from the explored data, you might want to clean the data, like which is not required in terms of if there are null values. So there's a lot of process ETL pipeline that needs to be run on cleaning the data. Then you go for feature engineering. Feature engineering is like you basically select features, like what all features you might want to have, the relevant features that you might want to have within your AI platform. Once you identify those features, you might want to do feature transformation on top of it, which is like if there are certain data that is required, and that can be transformed from some of the existing raw data, you might want to do that. You might also want to run some functions on top of it while doing feature engineering, so that you're creating those features which might not be available as part of data. Feature scaling is another important aspect, wherein you might want to make sure that all the features that you have identified, you have created, you have transformed in the previous step, they have an equal distribution when it impacts the overall performance of your large language model. So that's where the scaling comes into picture. I'll just let Akash talks about the next layer.
Once you have the data ready, you need to pick what kind of a use case you're solving and then which model will work for you. And without going into much detail, there are a lot of architecture available. The very fundamental, the first one is the transformer model that people have been using, but now there are multi-models and various other kind of models available that you pick for like what will work for your data and what will work for your particular use case. And once you've chosen, made a decision about a model, then you have to make a very critical decision about build versus taking something from off the shelf. So, Deepak, you want to tell more about that?
Yeah. So when it comes to building or choosing a LLM model, this is like one of the most important decision that you have to take as organization, because while doing this, you might want to consider multiple different attributes, or I would say multiple different uh, parts where you decide whether I want to build a model from scratch by using all my proprietary data, or I want to adapt a existing open source model that is available out there in the market. And there are multiple factors that basically comes while taking this decision. You might want to consider time while taking this decision. So while doing like building a custom large language model, it takes several months. For fine tuning takes less than a month. And when I'm saying less than a month, it basically involves your data engineering as well as fine tuning using the execution of this large language model and the exact data. Then comes the cost. Cost large language model building is like millions of dollars is required. And from fine tuning perspective, it's I would say $100,000 to $500,000. That's the range we have typically worked in doing fine tuning of any model. Computational requirement. OpenAI is a single system with more than 285,000 CPU cores and has used 10,000 GPUs and 400 gigabytes per second of network connectivity over GPU server. So that's like very big infrastructure that you require while building a custom large language model versus using a 56 GB of GPU memory for 7 billion parameters. I'm considering 7 billion as in average parameters that is available for any model. MLOps is also very important aspect because while building from scratch, it's very resource intensive operations versus, as I mentioned earlier, it requires a huge infrastructure for that. Fine tuning, it's off the shelf third party solutions available. You just pick one of those and start fine tuning it. Weight discovery is another aspect because now we have considering 7 billion parameters. So there are multiple discoveries that are required in order to get to that state where it works perfectly for our use cases. For fine-tuned models that are already available, it's already done. You don't have to do that weight discovery again. Retraining cost, again, multiple cycles, multiple huge data that is required. All these cycles is again very expensive. Comparatively, it's very inexpensive fine tuning. Data set requirement, just consider 7 billion parameters. So that's the data set that you need in order to develop it from scratch versus fine tune. They already have been trained, and all you have to do is bring in your own organization specific contextual data that is required here. Now, I just want to talk a little bit more around this off-the-shelf third-party solutions available. Akash, we've used that tool. I'm not sure. I'm not able to remember that. Where we were able to quickly see all the parameters while doing the fine-tuning.
Yeah, the graph book, Surbic.
Right.
So, so there are many solutions available to be able to modify an existing model and then being able to write your own large language model. But I think most of the organizations that we have worked with, the use case has been to take a model off the shelf, which has the right licensing available, and you can use it for commercial purposes. And there are actually several that works and provide a really good result. Currently, as of this call, Mistral is very, very active, and organizations are using this 7 billion version a lot for fine tuning on different use cases. Before this, we were using a Llama 2, and and few other options. So I would say that if you're interested in taking a base model as a next step, once you have made a decision that you are going to only fine tune and not build something from scratch, then you go to Hugging Face, you find one of the model for your particular use case, and then you start working towards it. And yeah, so go ahead.
So for fine tuning, there are multiple ways. One of them, like for most of the public large language models, there are APIs available. So OpenAI basically asks for a data set that is in this format, like you give a prompt, and then what is the ideal generated text based on that prompt. And you might want to have like, let's say, 5,000 to 10,000 different prompts and ideal completion. That's how you can, using the public APIs, you use this data set and quickly do the fine tuning. Another option is you take the approach of LoRa fine tuning, where it takes key and value as input. So that's where you can basically go ahead and do fine tuning of a specific model. And yes, you have to bring in your own data while doing that.
Yeah, and now just understand that we have gone and discussed various options on whether to build a model from scratch or whether to fine tune one. Now let's see what the results look like when you do that. So let's say you have a particular use case, and what we have seen is that around 80 to 85% accuracy for a given use case comes out of just using a method we call as RAG, which is a retrieval augmented generation, and where you basically have a knowledge base and a large language model, and then you are able to query through it. So a RAG is able to give you like 80 to 85% and sometimes even 90% accuracy in some of the use cases. But when it comes to improving the last bit and making it better, then it comes down to fine-tuning a model or building one from custom. So if you look at this, if you have a use case where 80-90% accuracy is good enough, and you have a human in loop to be able to review the answers given by a large language model, I think you can just do a RAG approach, and you will be able to get a really good results. And this is a very quick approach, and this doesn't require too much of engineering and preparation, and you get the results very quickly. When it comes to actually, going from 80-90% to like 99% of the accuracy, that's where you have to do fine tuning. You have to do RLHF, which is basically a process to go back and get the feedback from human beings, and that feedback is applied back into the process to be able to improve the results. But this is a continuous process, so I don't think we ever get to like 100% accuracy with any of these models, although there are being some approach which will allow us to do that. So
right, and it's more of a continuous process where you keep getting the human feedback, you keep rewarding the model, you keep retraining the model, and that's how you change the policies. If something needs to be ranked way below, or something needs to be ranked above. So you keep rewarding those outputs and keep improving your model as part of this whole process.
Correct. And I think we promised in the beginning of the call that we will give you insight of how to do a very quick implementation of AI within an organization. And there are a lot of frameworks available, and we also happen to have one of the framework called ZBrain. And what it does is it's an enterprise platform that allows you to create a use case. It's able to take the data sources that you have very quickly, digest it, prepare the data, and then being able to give you the interface required to communicate with the data and ask questions and build use cases on it. So this is a very more like a technology slide that I will say. But at a high level, it takes the enterprise data in, and then it's able to produce the results based on the interfaces that you will have and various use cases that you will have. And we have built all the capabilities required to be able to use the process. So, for example, if you need the governance tool to be in place, you need to convert unstructured data into more structured information for large language model contextual prompting. So all these things are available as off-the-shelf solution within the platform. So you can check out zbrain.ai if you want to find out more about how to do this.
Yep. So quickly summarizing what we have covered in this entire conversation today, Akash, the entire AI strategy that basically covers the AI vision, that covers the strategic goals from an organization perspective, and then actually going into the field and taking actions for this. So we've tried to define it like three parallel things that needs to be done. One is at an organizational structure, wherein you understand the entire organization setup, their offices, their organization structure, what are the processes involved, human processes or any automation that is already available, roles and responsibilities of different team members, skills available, capabilities available across the team, what's the budget you want to bring in, and then in the end, what's the revenue, or when it comes to internal processes, what is the efficiency that you are able to achieve as part of the organization structure. Now, from a AI fast track use case perspective, as we talked about, quickly identifying use cases, strategic use cases, make them very specifically or buy them. That's different, two different things to be considered. Quickly doing the prototyping, and then keep improving the technology stack business model during the whole development process, and then industrialize it. From technical infrastructure for AI, you might want to understand what is the current enterprise IT infrastructure looks like, whether it's cloud, on-premise tools that are being used, any CRM tools, any tools where data is being stored. We have talked a lot about data, IT workbench, methods and models that are required. We've talked about various options, how to move forward, various models we've talked about, standards from a governance perspective, and then you basically take it out and create that ecosystem and network of agents, and these models can basically cover this entire AI framework, I would say. So that's pretty much in a nutshell what we have covered so far.
I think this is a great insight on how do you really get ready for AI. Again, going back to the vision, we believe that every organization needs to be ready for AI, and then all these components has to be put in place. And thank you very much for staying back and attending this and participating in this webinar. We are happy to take some questions. Deepak, I already see some questions mentioned, so let's take that.
Sure.
The first one is, how do you address regulatory compliance requirements such as GDPR, HIPAA when working with large language model that process or generate personal or confidential information? You want to answer that?
Sure. As we discussed, if you are going for, let's say, a private deployment within an organization, so whether you, it's completely up to the governance layer that we have defined on how to store that data. And typically, most of the organizations already take care of these compliances. We are not taking our information outside our ecosystem. So really, GDPR or HIPAA compliant that are being already part of the organization. So that's pretty much covered. Another aspect is, let's say, if we have to go out with our information to the public LLMs, if we have to use them, they might be a good choice for some of the use cases. Then you might want to go ahead and do the risk and governance that is already being taken care as part of our ZBrain platform. However, just to explain a little bit more here, so you have the context, you have certain entities and identities within that context and data. So you might want to remove all those real entities and real identities with the synthetic entities and identities. You replace them, you take this context, you take your data, you go out, you get the response, and then replace those identities and entities with the original ones. That's how you are able to basically not sharing any personal information which is very close or important within the organization outside your ecosystem. So that's more or less how you can cover that part.
The next one is
Yeah.
how do you handle domain-specific challenges during the fine-tuning process, particularly when adapting pre-trained models to new domains or industry? So the answer to that is that there are a lot of models available, and especially the GPT models are trained on very large parameters. And the more the parameters are, the more type of problems it can solve. And typically, when you're doing a domain-specific problem set, it will depend on your. I think the burden lies on the data set that the organization is bringing to the table while fine-tuning. Sometime in, let's say, a use case of customer support, it's much easier, and we have seen the results are very fast, where you just fine-tune a model with some, archive of previous tickets and FAQs, and the model really resolved very well because it is mostly natural language interaction between two people. But when it comes to creating complex solution, let's say you're doing drug discovery, you're doing something else which is very proprietary, then in those kind of use cases, you will need to bring in a lot more, much more larger data set to be able to solve this problem. There is another one question from Jane. What would be the typical engineering resources needed from your clients on the average large language model implementation project? So Deepak, you want me to answer this?
Yeah, Akash, please go ahead.
Okay, so I think the typical, the first use case that people end up building is around, like let's do a quick POC, show it to the stakeholders that this thing worked. And that doesn't require much because platforms like ZBrain, you basically deploy this within your organization. So you need a very part-time IT people involved, a little bit of project management, and then you deploy this solution within the organization and then connect it to a data source. And you almost kind of immediately get to some results. And you're able to ask some questions, get some answers. And that process doesn't need too many people involved. You just need a prompt engineer, a little bit of IT and project manager to be able to do this. However, if we go into the process of full-time, I think doing fine-tuning, then there will be a lot more people involved, and that will depend upon the size of the data that you bring to the table, and also the use case, how complex that is. So I would say that just to do a 80-85%, and I'll go back to that slide where we demonstrate that getting to 80-90% accuracy is mostly doable through this: connect the data to a large language model, do a good prompting, and you are able to get a really good results with minimum efforts. So,
and yeah. So just to add to that, you might, so when it comes to fine tuning, you might want to bring in your domain experts, because those are the people who will be creating those data set that is required to fine tune. So that's what is required as part of fine tuning. As I mentioned, creating the data set is the most important aspect. So it's a very basic principle when you're doing fine tuning. You give in the garbage, you get out with the garbage from LLM. So the better data set you bring in, the better results would be there. So that's what we have seen while doing fine tuning.
Do you have role metrics on actual projects? Example, workloads, savings in admin process to justify the investment? Um, it depends on the organization to organization. We don't have like a very clear metrics, but we have definitely seen in some use cases bringing around 70 to 80% efficiency and cost cutting when it comes to like customer support. And it's like a no-brainer, because a lot of the customer support, and we did it with some very large organization, and also did it some use cases with uh, small to medium company size companies, and we saw that customer support replacing a bot on a website to answer some question, that kind of a use case really bring in efficiency and cost down to almost like just being 10%, 20% of the actual cost, and you need less of the resources to do this with while implementing AI. So I would say that it again depend on the use case to use case, what it will be, but we don't have like any actual metrics. But the whole purpose of applying, this whole generative AI is to either make better decision or, bring efficiency to a process. So that it do results in that it does most of the time.
Yep. And another thing to consider is you never want to start with, you don't want this AI tool to like remove the entire dependency on a human being, the manual process. So even if you are able to achieve, let's say, 50-60% of the efficiency, you're actually talking a lot of savings here. And these use cases can easily be developed using some of the tools that we have mentioned.
Right. Next one is, how can we address potential concerns regarding data privacy, security, compliance when deploying large language model in our business operation? Deepak, you want to answer that?
Yeah. So I think I have answered a couple of points in my first of our question that we considered, where we talked about compliance. When it comes to security, again, we are creating this entire AI framework within our ecosystem. So the security is as good as any other application that is running within your organization. So that's from security perspective. Compliance we have already taken care of. Some of the important aspects that we should consider while doing this is guardrails, which effectively means, let's say, if we have a bot or AI tool that needs to respond back within a specific context, so it stays within that context. So any generic questions coming in, it should not be responding back. So using some of the open source libraries from NVIDIA that can be used here to configure the context, to configure what not to answer, because that's very important from legal aspect also, that you only stay in that context. So that's how we can do that. And validating before responding back is one of the most important step while implementing these use cases.
Yeah, I think there are two parts to it. One is guardrailing, like Deepak said, through various tools, and the other one will be, validating the data, and I think that's very critical. How do you validate that result that comes out of it? So we can get into that detail of that, but I'll take one more question today. What language does data have to be in to be entered into a pre-trained model? Are there translation capabilities? Angela, the answer to that is actually very simple. Most of these models are trained on multi-language, multilingual. And the way, these algorithm work is, we convert all these language into a format that the machines understand. So actually, at the end of the day, you can have it in English or any other language. These are all converted, and we call the process as tokenization. And when we do that, the everything becomes like a common language for AI to understand. And then when it brings it out, then it is able to convert back into the relevance of what it believes the answer should be in. So let's say you have a data set in French and the model is English. It will still work out, and we have seen, and actually we have tried that. And the reason is because most of these large language models are trained on various data sets, and they're capable of like understanding languages across the board. So you could have the data in any language that is needed. One of the question here is, Deepak, we all know that LLM does hallucinate. Is there a way to distinguish which one is accurate response and which one might have hallucination?
Right. I think we briefly covered that, but just to elaborate on this topic, the most important aspect is to basically validate the response against the data source that has been used. So validation is very important point here. The other one is to make sure it stays in context. You can always use RLHF technique as one of the techniques to make sure hallucinations goes away, but that takes over a period of time. When you are like retraining that model, you're changing the ranks, you're giving those models the human feedback. So that's how you do it. Even if you do that at a LLM level, you still need that layer which validates the response against the context as well as against the data source that has been used. So that's what we have to do while doing making sure the LLM or the overall solution does not hallucinate.
Yeah,
That's
and it's been solved. This is the biggest problem in the industry. A lot of solutions are out there, and we have seen that one of the solutions is that, like Deepak mentioned, you have index of the all the resources of your data, and then let's say the model spits out some text and content. Then what you do is you validate the output through the indexes which are available to you, and then make sure that there is some source that is relevant to that particular index and to that output that LLM produce. And that's the best way of making sure that there is least amount of incorrect data. And this approach is being used by multiple companies now in order to just make sure that the model is not hallucinating. And I think with time, this will automatically come as part of these large language models, and it will start to reduce the hallucinations. So we'll take a last question here. Deepak, it's about building enterprise-grade large language model involves significant investment and resources. Can you provide insights into the optimal approach for balancing in-house team and external partnership, particularly for large-scale companies?
I think we've tried to cover that during our whole presentation. So go for that first use case. And there could be two approaches again. One approach is by finalizing the use case and seeing what data source is required, whether it's internal data or for that matter, public data source that is required in order to achieve that. Or you can go bottom up, which is you have the data with you and you might want to see how best I can utilize this data to achieve maybe multiple use cases. So those are like bottom up and top down approaches. Cost wise, I would say initially to achieve this, they are very cost effective if you go with RAG approach. Fine tuning is, we have already mentioned a range here in terms of costing. And the final one, which is training from scratch, is I've not seen most of the organizations coming to us really
Okay,
wants
good.
that. Yeah.
Yeah, great. This has been excellent conversation, and I want to thank you everybody who joined in today. And we really appreciate you staying around and asking really good questions. We look forward to seeing you in the next webinar. Thank you very much for joining.